Alright guys, welcome to your Unit 4 test study guide. Once again, I'm providing you guys with the odd answers on the worksheet here, and I'll be going over the even ones here. So for the first set, we're being asked to solve the quadratic equation using the quadratic formula. So, to begin with, we want to make sure that we do have a standard form quadratic equation that is equal to 0. If you do, then you're ready to roll. I'm just going to go ahead and do my little setup here that I like to do first. All right, we're going to plug in the b value. And we plug in the a value. And then finally, b value. All right, and then we simplify our 4 pieces that I've mentioned before. This becomes positive 4. And that's going to be interesting. Let me bring up my calculator here. I'm not going to try to figure that out now. So we have 4 times 10 times negative 22. Negative 880. In the bottom here. So we have double negatives, which happens once in a while. When that happens, you change them to positives. And so now we have 2 plus or minus the square root of 884, which is a pretty big number, all over 20. The next thing we got to do is we got to deal with this. So we have the square root of 884, and to simplify that, for these types of problems, I'm going to actually be asking you guys to break it down. So I can see that 4 goes into this thing pretty nicely. 4 goes in there 221 times. Now we're in a pickle. What the heck goes into 221? I don't think 3 does. Let's experiment here a little bit. I know 4 won't go in there. 5 won't go in there. Let's try 6. 221 divided by 6. Probably not. Let's try 221 divided by 7. How about 221 divided by 8? No? Well, we're having no luck here, so my guess is maybe it doesn't get divided by anything. Tried 11. Let me try 13. Ooh, what do you know? 13 went in there. Yowzers. But you know what? It doesn't really matter because even though 13 went in there, it only went in there 17 times, and those are prime numbers, so can't really break either one of those down anymore anyway. So we have that. We have, so 2 times 2, 13 times 17, and we have a pair. Take that pair out. So we're just going to put that. The reason I said it didn't matter earlier is because we're just going to put those back together, and it's just going to go right back to being 221. Okay, so now my little expression over here becomes 2 plus and minus 2 square root of 221. And then, of course, you want to reduce if you can. You can only reduce if all 3 of these numbers can be reduced. If they're not all there, then you can't reduce. In this case, all 3 of those can be divided by 2. So if I divide them all by 2, I'll be left with and we're good to go. The one here that we have in front of this 220 is not necessary, so you can erase that. Kind of like when you have a 1 in front of an x, you don't need to write it, right? So Anyway, there's our solution for number 2. Go ahead and take a look at our next even problem. Now, this is also a quadratic equation, but it's not in standard form, but something else special about these numbers 3 and 4. What's special is, first of all, look at the directions. It's telling you how to solve it. It's telling you to solve it by taking a square root. But the thing that kind of points out to you that that's how you're going to do it, other than the directions, is the fact that there's only one in here. There's only one variable. Whereas if you look back at like number 2, there were 2 variables. So when there was only one in, basically you could just solve it using old school algebra. You don't need to use the quadratic formula. I'm going to minus the 5 on both sides. We're going to divide by -2 on both sides. And then we're going to take the square root on both sides. And the only thing we really need to trouble ourselves to remember, the fact that when you solve it, taking square root, you get plus and a minus. So the square root of 9 is 3, so our answer is plus and minus 3. So we get 2 answers, positive 3, the negative. Another problem here. All right, they want us to sketch graphs for numbers 5 and 6 of the parabolas. So whenever you want to graph a parabola, you're going to have an a value, an h value, and a k value. The h and the k, once again, make up our vertex, kind of like they did for the absolute value function that we talked about. And then the a, it tells you whether the graph's going to be wide, stretched, or normal, but that doesn't really matter very much. Probably the only thing we really need to pay attention to get the correct answer is whether a is positive or negative, because a positive a is a happy face parabola, and a negative a is a sad face parabola. And that'll probably be enough to give us our information. Just remember that if you are ever missing some numbers from the equation, if you're missing an a, that means it's a 1. If you're missing an h or a k, that would make them a 0. So when I'm looking at this problem here on number 6, I see my h, I see my k, but I do not see the a. So that means it's a 1. My vertex is going to be those two numbers, 4 and 1, but remember, when you do this, the h changes sign. It's actually -4. And since my a is positive, I'm going to have a happy face parabola. So it's starting off at my vertex at -4, -1, which is going to be like right there-ish. And it's a happy face parabola. And that's probably good enough to get a pretty good estimate of which answer is the correct answer when you're looking at your multiple choice. Okay. That's how you graph a parabola in vertex form. Now let's talk about how to graph a parabola in standard form. Standard form is a little bit more of a pain in the butt to figure out how to graph. First of all, we're going to identify the y-intercept. The y-intercept is basically always going to have 0 for the x value, and the y value is going to be whatever comes last there, the c value. So 0, 2 is my y-intercept. Next thing we need to do is we need to find our vertex. Now, finding the vertex is a little bit more work, okay? To find your vertex, the first thing you got to do is you got to find the x value, and then you got to find the y value after that. So to find the x value, what you do is you do the -b over 2a formula. So my b value is 4, my a value is 1. So I have -4 over 2, which is -2. I've got my x value for the vertex. Now I need to find my y value. The way you find your y value is by plugging the x value that you just found into your original equation for the quadratic. So I'm going to take my equation of y equals x squared plus 4x plus 2. And I'm going to plug my x value in. When you do this, you've got to remember to do your exponents before you do anything else. And then you do multiplication after that. Finally, you go ahead and just add and subtract. So 4 take away 8 is -4, and if you add 2 to that, you get -2. My y value is also -2, so my vertex is -2, -2. So I've got 2 points. The last thing that we're going to do is we're going to go ahead and just find our a value, whether it's positive or negative. If you have a positive a, remember it's a happy face. If you have, oops, my screen went crazy. If you have a negative a value, it's a sad face. Okay? And in this case, we have a positive 1 for an a, so we have a happy face parabola. All right. Let's go ahead and see what shakes loose then as I try to graph this. So my y-intercept is 0, 2, which is going to be like right about there. My vertex is -2, -2, which is going to be like right about there. And as we know, it's a happy face parabola. So I'm going to go through my vertex right there and my y-intercept. That's how you graph a quadratic in standard form. Okay. Another thing that we learned how to do was how to change a quadratic in standard form into a quadratic that is in vertex form. And I would encourage you guys to look at your notes from that lesson. I believe it was lesson 4.3 or 4.2. My memory is letting me down here. But on those notes, there's some steps that I gave you guys. Okay, and those are the steps we're going to use to solve the problem. So here's how we're going to do it. Step 1 is to move the c. So in this case, that's the 9. So I'm going to -9 on both sides. Next step is to factor out the a. So that means we're going to divide the a out of these first two terms. Left my y out of there. All right, so if I divide -2 out of here, I get positive x squared. If I divide that by -2, I get -6x. The next step we do is we complete the square. That's a nifty little move where we actually create a new number in the parentheses. We're going to take this middle number, we're going to cut it in half, and then we're going to square that. And then you put the answer there. After you've completed the square, we need to fix the balance. We just made our equation unbalanced by adding a number on one side and not the other. It's no longer equal. So we need to fix that so it stays equal. And the way you do that is by multiplying the number outside by the number you just created. So that's -18. And whatever that result is, you're going to add that over there. So I'm going to add a -18 on this side. Okay, next step is to factor and simplify. When you factor your perfect square trinomial, you'll always get a x in a set of parentheses with a square outside of it. The only thing that ever changes is this number here, which is always going to be exactly half of that middle number. So we're going to have a -3 there. Over here, we're going to simplify by putting the -9 and -18 together to get -27. And then our final step after that is to add the k over. The k in this case is the 27. Doing all that, we end up with our new expression here, which is the same quadratic we started with. It's just now that it's written in vertex form instead of standard form. There you have it. Go ahead and check out yet another type of problem you need to be ready for. Solving systems of equations that involve quadratics. Okay, so when you have a system of equations that involves quadratics, we're going to use the substitution method. And in the substitution method, you find a place where it says y equals. You circle what it equals, and then you plug it in for the y in the other equation. So if I do that, I end up with 3x squared minus 5x plus 3 equals x squared plus 2x minus 7. Now what we're going to do is we're going to combine all of our like terms together by moving everything into one side. So I'm going to subtract this x squared on both sides. I'm going to subtract the 2x on both sides. And I'm going to add the 7 on both sides. That way, everything over here cancels out, and I'm left with just 0 on the right. On the left, if I combine all these things together, I get 2x squared minus 7x. And so now if I wanted to solve this new quadratic equation that's set equal to 0, I can just use my regular old quadratic formula, which we already went over in question 2. So I probably won't be explaining as much here. If you're not too sure how to use the quadratic formula, you might want to go back to question 1 and 2 and study those up a little bit. So this is going to be 49 and 80, which is going to be actually 49 minus 180, I think. Weird answer of negative 31. Now, as you guys remember, when you have square roots that have negatives underneath, we're going to take the negative out and put an I on the outside. And that's where we're going to stop because we can't go any further. And just so you guys know, for these questions, I usually intend to give you ones where what happens is you can actually get an answer. And also the square root, I'm going to try to make sure that those are really nice numbers. So like, for instance, it would be really nice if we had 36 there, right? Because the square root of 36. So I'm going to be giving you guys problems on your test where they work out nicely. This can also happen. And here's what happened on this one. We end up with a negative number under the root. And when that happens, we get an imaginary number. And what that means is that there's no solution. Okay? In other words, if I were to graph this parabola and this parabola, they actually would not intersect. They don't have any points. Okay? But just in case, whenever you guys are working on number 11, you're probably going to get a nice answer. Now, once you get your answer, you'll probably end up with 2 of them. One of them is your x. Actually, both of them are your x values. So you're going to take each of those answers that you get and plug each one of them in to your equations at the beginning, find the y value that goes with each one. So then you should end up with 2 coordinates at the end of where they intersect. It could just be one answer too. All right, let's go ahead and move into our word problems here. All right. You're going to be tested on the projectile questions, and as you guys know, when it comes to projectiles, we're going to be using this little formula here. All right, and so let's go ahead and look into it a little bit. It says a golf ball is hit from the ground, so that's important. That tells me that my starting height is 0. And it says we have an initial vertical velocity of 70 feet per second. That's another important number in there. That tells me my starting velocity is 70. All right, so the first thing you want to do is change your equation to have those values in there. And since my starting height is 0, you can put plus 0 if you want to, or you can just leave it off. It doesn't really matter. Let's go ahead and continue then with the problem. So before you can even answer any of the questions, that's what you're going to need to do, is you're going to need to plug the numbers that they give you into the projectile formula that we discussed. All right, so they ask for the maximum height of the ball. Well, when it comes to quadratics, you guys, the max height is the vertex of the parabola. So when they're asking for the maximum height, what they're really asking for is they're asking for for the y value of the vertex, which we discussed how to find that in an earlier problem in the study guide. The first thing you have to do is you have to find the x value, and you find that by doing your negative b over 2a. And you're not going to end up with pretty numbers on these problems, and that's okay. Go ahead and round it to the 10th place. What does it say here? It says round to the nearest thousandth place. Whatever. All right, I'll round to the thousandth place. If you don't know what that is, I'll show you in a second. 2.187. So the 7 is in the thousandth place. So we look at the number before it, which is 5. And anytime the number, before it is 5 or higher, you're going to bump the number up that you're interested in by 1. So I'm going to actually have 2.188 time value there. And yes, that is a time value. Now to find the y value, which is what we really want, which is the maximum height of the ball, once again, basically we're just going to plug that in to our formula here. I'm not going to include the 0 because I ran out of space and I don't need to include it anyway. Okay, so now I'm going to square first, just like I said last time. You always do your squaring first. All right, then bring up my calculator to square it. .188 squared is going to be 4.787, and once again, if I round it to the thousandth place, that's going to be 7. So all right, next we do our multiplication. So I'm going to multiply these and add the results together. So let me bring the calculator yet again. So negative 16 times 4.787 equals that. Now I get to do the other one. 70 times 2.188. And that's 153.6. So I'm going to add 153.16 to a negative 76.592. So I'm just going to put plus, and then equals. And there's my final height. I'm ending up with 76.568. And those are always going to be in feet. The time is always in seconds, and the heights are always in feet for the projectile problem. All right. So next thing we'll do is we'll go ahead and move on to part B of this question, which asks us how long does it take to land on the ground? Well, if you think of an object that's been launched and it lands on the ground, right? What we're really looking for is the roots, and the way that you do that is with the quadratic formula. Okay, so we're going to take our little expression here of, well, so h of t equals negative 16t squared plus 70t plus 0. And we're just going to plug that right into our quadratic formula. And for this problem, once again, we're just going to use the calculator. We're not going to break it down the way that we did last time we used the quadratic formula, just because it's pretty tedious to do that. And besides, the problem tells us to write it in decimals and round it to thousandths anyway. So we'll do all the work for us. All right, so we have negative 70 plus and minus. Now, this whole thing cancels out in this case because it's just 0. And if I did 70 squared and then took the square root of it, I'm just going to end up with 70 again. Now, for you, just be careful. If you don't have a 0 here, yours won't work out that way. You still have to actually get out a calculator and punch it in and work it out. In this case, I got lucky, so I had a little bit of an easier one. All right. And at this point, we do have to go ahead and take the time to write two separate problems. One where we're going to add the 70, and one where we are going to subtract the 70, because we have a plus and a minus. So for this one, if you add 70 to a negative 7, you get 0 over 32, which is just 0. For this one, we get negative 140 over negative 32, which my calculator, I can get a good answer in decimal form there. So negative 140 divided by negative 32. My 140 wasn't negative. It should have been. If I had punched it in right, it would have come out positive. I just forgot to put the negative 140. So it's actually a positive 4.3. And remember, that's in seconds. So it took 4.375 seconds. Okay. Now, there's lots of other stuff that we could do here. I could ask you, how long does it take to land to reach the maximum height? Well, we already found that actually. It was 2.188 seconds because it's just the x value of the vertex. Another thing I could ask you guys with these is I could say, what's the height of the ball at 5 seconds? So if I tell you that at 5, well, that's actually too long because after that the ball's already landed on the ground. Well, let's say I just asked you guys, what's the height of the ball at 3 seconds? Well, basically you just plug this in e into your formula and simplify it and you'll get your answer. Okay. And another type of question I could ask is I'd say, okay, let's say that the height is 20 feet. At what time does that happen? In that case, you would plug 20 in for the h of t, and you would use the quadratic formula again. And very often for those ones, you're going to end up with two answers. But anyway, just kind of quick little review there. That's number 13. All right, let's go ahead and take a look at number 15. Number 15 has quite a few things on it. It's asking us to find the average rate of change. Then they want us to know if it's increasing, decreasing, or neither, and so on. So we'll go ahead and just start with the first one and work our way through it. Let's do part A, average rate of change. Okay, so to find your average rate of change, basically, we need to find, we're going to use these two x values. The bigger one goes here, and you put minus, and you put the smaller one. And then we're going to find the y values for each of those x values on the top. Okay, so I need to plug 0 in for f, and I need to plug negative 3 in to my function. So instead of y, I'll call this f of x. It doesn't really matter. So let's go ahead and find f of 0 really quick. So if I want to find f of 0, I'm just basically plugging 0 into the equation. So those two go away, and I'm left with negative 5. So f of 0 is just negative 5. Next, we need to find f of negative 3. So let's do that. Same thing, we're just going to plug it into the quadratic. Square that, I get 9. multiply these two numbers, negative 2, and you end up with a positive 6. So I've got 15 minus 5 is 10. So I end up with 10 there. And so I've got negative 5 minus 10, that's negative 15. And then 0 minus a negative 3 is positive 3. So negative 15 divided by 3 is negative 5. Final answer, that's my average rate of change. Now the next question, is the function increasing or decreasing on that interval? Well, since it's a negative number, it must be decreasing. When your slope or your average rate of change is negative, your function is decreasing. If it were positive, I would say that it's increasing. All right. All right, let's take a look at another question here. Problem back there, I lost it. There we go. It says find the average rate of change of this function on the interval from 0 to 3. So we're going to do the same thing. It's just that the setup will look like this time. Okay. We already found f of 0. F of 0 we saw earlier was negative 5. Now we need to find f of 3. So I'm going to plug 3 into this up here. And so 9 minus 6 is 3, and 3 minus 5 is negative 2. So there's that. So I just used my answer from the last time I did a problem for f of 0. And just slow down a little bit, moving a little bit quick through this. Remember, your big number comes first. The number, I did that, and the corresponding y values go above it. So that put us there. And then I calculated f of 3, which was negative 2. All right, now we have double negatives. So that's a positive. Negative 2 plus 5 is 3. The bottom is 3, and therefore got a slope of 1. And so that's answer to number C, or letter C. Now, is it increasing or decreasing on that interval? Well, now it's a positive slope, right? So now it's increasing on that interval. So the function was decreasing on this interval, but now it's increasing on this interval. Party is asking me, is it concave up or down, right, on the interval from negative 3 to 3. All right, now for that one, we made a little chart. We started by picking some x values. Now you only need 4. I'm going to use some of the numbers that I've already used here. I'm going to use negative 3, 0. We'll make one more number here, and 3. And then we're going to find the y values that go with it. Now, on earlier problems, I already found all the y values for most of these. When we plugged in negative 3, what did we get? 9, positive 6. I believe we got 10. And then when I plugged in 0, we got negative 5. And when we plugged in 3, I believe we got negative 2. The only one I haven't done yet is 1. So let's plug in 1 now and see what that one comes out to be. 1 minus 2 is negative 1. Take away 5 is negative 6. So there you go. So basically, just pick 4 x values on the interval that they give you. So we needed to pick 4 x values from negative 3 up to positive 3. Okay. I picked negative 3, 0, 1, and 3. After you find those, plug them in up here to find the y's. I already did most of that work earlier, so I just copied my answers, but I had to find this one. So there we are. All right, now the next thing is you need to find your delta y. In other words, you need to find out how much did your y's change by. Well, as I went from here to here, if I go from 10 to negative 5, that's actually going down by 15. And then if I go from 5 to negative 6, that's going down by 1. And then if I go from 6 to negative 2, that's actually going up 4. Okay? Then we need to find our delta x's. In other words, how much of the x is changing each time. From here to here, it's up 3. From here to here, it's up 1. From here to here, it's up 2. The next thing we need to do is we need to find our slope. And to do that, you do the delta y divided by the delta x's. Okay? So, for instance, my first delta y is going to be divided by my first delta x. So if I do negative 15 divided by 3, I end up with negative 5. Then we repeat it with the next pair, negative 1 and positive 1. If I do negative 1 divided by positive 1, I get negative 1. Then I do the next one. Positive 4 divided by positive 2 is 2. Okay, so then the next thing we do after we find those slopes is we ask ourselves, is the slope increasing or is the slope decreasing? Well, as you can see, I'm going from negative 5 to negative 1 and then to positive 2. My slopes are increasing. And when your slopes are increasing, that tells us something about the concavity. So our last thing that we're going to do is we're going to decide, is it concave up or down? And since my slopes are increasing, that means it's concave up. And that's my final answer. So is the function concave up or concave down on that interval? And then it says explain your answer using the data you gathered in parts A through D. Well, I used my data from parts A through D to get these y values here. And also you could tell the answer from the slopes too. But either way, I'm explaining my answer here with the table that I shared with you guys. So we found our x's, we found our y's, we found our deltas and deltas, and found our slopes, and we found that our slopes are increasing. Therefore, it's concave. All right. And that does it. So on this one, I accidentally did the odd one. I meant to do the even one, but oh well. We'll live with that. I'll let you guys do the even one on your own. But if you have any questions, feel free to